Hi, this is Alex from devstories.eu. Shapely, Episode 8 of 8. Comparing a single point against a million polygons takes massive compute time, yet some applications do this in milliseconds. They do not calculate every distance. They filter out 99% of the data before doing a single math equation. This is high-performance spatial indexing with STRtree. Say you want to find the nearest coffee shop out of 10,000 locations to a user's current GPS coordinate. If you calculate the exact distance to every single shop, your system will crawl to a halt. Instead, spatial indexing uses an R-tree. Think of an R-tree as a hierarchical folder system for two-dimensional space. It draws a simple rectangle called a bounding box or envelope around clusters of nearby geometries. Then it draws bigger boxes around those boxes. Checking if two simple rectangles overlap is a computationally cheap operation. In Shapely, the specific implementation is the STRtree, which stands for Sort-Tile-Recursive. You create one by passing an array of geometries into the constructor. Under the hood, this bulk loads the index. The tree is built once and is immutable. You cannot add or remove items after it is created. You must prepare your entire dataset up front. Once the tree exists, you search it using the query method. You pass an input geometry and the method returns a NumPy array of integer indices. These indices map directly to the original sequence of geometries you used to build the tree. If you input multiple geometries at once, query returns a two-dimensional array, pairing the indices of your inputs with the matching indices in the tree. Here is the key insight. The base index of an STRtree only checks bounding boxes, not exact geometries. If you query a complex polygon, the tree uses the square envelope of that polygon to find matches. This gives you a short list of candidates containing false positives. To get an exact answer, Shapely allows you to pass a spatial predicate, like intersects or contains, directly into the query method as an argument. The tree first uses the cheap bounding boxes to find candidates, then automatically evaluates your exact predicate on that shortlist. This keeps the heavy mathematical lifting down in the compiled C code. Beyond overlaps, the STRtree excels at proximity. Returning to our coffee shop scenario, you do not need to check envelopes manually. You use the query nearest method. You pass your user's GPS point, and the tree traverses its hierarchical boxes to find the absolute closest geometry without measuring against all 10,000. It immediately returns the index of the nearest shop. You can also specify a parameter to return an array of the top n nearest neighbors, or set a maximum distance threshold to limit the search radius entirely. There's also a distinct nearest method, which compares two separate trees against each other to find the closest matching pairs of geometries between them. The actual geometry operations are always the most expensive part of spatial analysis. The STRtree acts as a ruthless filter. It prevents you from wasting CPU cycles on geometries that are nowhere near each other, providing a tiny, manageable shortlist so your exact mathematical checks only run when they absolutely have to. This wraps up our series on Shapely. I highly encourage you to explore the official documentation and try these indexing concepts hands-on in your own datasets. If you have workflows or tools you want covered in future series, visit devstories.eu and drop us a suggestion. Thanks for tuning in. Until next time.